look up at the night sky. For thousands of years, humanity has gazed at this celestial canvas, feeling awe and wonder. We've told stories about the stars, charted planets, and slowly begun to understand our place in the cosmos. But what if everything we see is just a fraction of the whole story? What if the universe is far more complex and mysterious than we can perceive? Science has always revealed the unseen, showing us deeper layers of reality with each discovery. Now, the idea of hidden dimensions, beyond the three we know, may be the next great leap in our understanding. This isn't just science fiction, it's a concept born from our most advanced theories. So, let's embark on a journey to explore the possibility that our universe has hidden depths and that reality is far richer than we ever imagined. The word dimension might sound technical, but it's actually simple. A dimension is just a direction you can move. A point has no dimensions. Add a line and you have one dimension forwards or backwards. Add another direction at a right angle, and you get a flat surface, 2 dimensions length and width. Add a third and you can move up or down, 3 dimensions length, width, and height. We live in this three-dimensional world, describing everything with X, Y, and Z. Each new dimension is perpendicular to the previous ones, opening up new possibilities. It's easy to imagine up to 3, but what if this process doesn't stop there? What if there are more directions, more dimensions beyond our perception? The idea is mind-bending, but it's at the heart of some of the most exciting theories in physics. Let's see where this leads. We move through 3 dimensions of space every day, but there's a fourth time. When you meet a friend, you give them a place and a time. Both are needed. Einstein showed us that space and time are woven together into a 4-dimensional fabric, space-time. Time is different from space. We can't move freely back and forth, but it's a dimension all the same. Every event in the universe has a location in space-time. Even sitting still, you're moving through time at 1 second per second. Your life traces a path, a world line, through this 4-dimensional universe. This framework lets us predict orbits, understand gravity, and build technologies like GPS. For a long time, 4 dimensions seem to be the whole story, but new theories suggest there may be more. The idea of extra dimensions first appeared in the 1920s, when Theodor Kaluza, a German mathematician, made a bold leap. He extended Einstein's equations of general relativity, which describe gravity in our familiar 3 dimensions of space and 1 of time, to include a mysterious 5th dimension. This was a radical idea at the time, challenging the very foundation of how we perceive the universe. Astonishingly, this mathematical extension unified gravity and electromagnetism, 2 forces that seem completely separate in our everyday world. Suddenly, the equations describing the force that holds us to the Earth and the force that powers lightning and magnets were woven together in a single elegant framework. But if a 5th dimension truly exists, why can't we see it or feel it? Why does our experience of reality seem limited to just 3 dimensions of space? Oscar Klein, a Swedish physicist, offered a fascinating answer. He proposed that this extra dimension might be curled up like a tiny circle at every point in space, so minuscule that it escapes all our attempts to detect it, even with the most powerful microscopes or particle accelerators. Imagine a garden hose lying on the ground. From far away, it looks like a simple line, a one-dimensional object, but as you move closer, you notice its circular cross-section, a hidden dimension that was invisible from a distance. This is how Klein imagined the extra dimension, present everywhere, but hidden from our coarse perspective. Klein suggested the universe's extra dimension is like this, hidden, compactified, and billions of times smaller than an atom. It's so tiny that even the particles that make up atoms can't move through it in any noticeable way. This Kaluza-Klein theory introduced a revolutionary idea. The universe's dimensionality might depend on the scale at which you observe it. What seems like a simple 3-dimensional world could hide more complexity, revealed only at unimaginably small distances. To us, space seems 3-dimensional, but on the tiniest scales, there could be more directions to move. Hidden axes that only become apparent if you could shrink down to the size of a proton or smaller. The original theory had flaws, and physicists eventually set it aside, but it planted a seed, a tantalizing hint that the universe might be far richer and stranger than we ever imagined. Decades later, this idea would return in a new, even more ambitious theory. Enter string theory, where hidden dimensions aren't just possible, they're essential to the fabric of reality itself. Physics has two great theories: general relativity, which describes the vast, majestic dance of planets, stars, and galaxies, and quantum mechanics, which governs the bizarre, unpredictable world of the very small, atoms and subatomic particles. But despite their individual successes, these two pillars of modern science don't fit together. Like mismatched puzzle pieces, they leave a gap in our understanding of reality. The quest to bridge this gap, to find a single theory of everything, led scientists to string theory, a bold and imaginative idea. Instead of point-like particles, string theory proposes that the universe's most fundamental building blocks are unimaginably tiny, vibrating strings of energy. Each particle we observe is just a different vibration or resonance of a string, much like how different notes emerge from the same violin string depending on how it vibrates. The universe, in this view, is a grand musical instrument. The cosmos becomes a vast symphony, with the laws of physics acting as the rules of harmony and rhythm, guiding the interplay of these vibrating strings across the fabric of space and time. But here's the twist: string theory only works if the universe has more than the four dimensions we experience. It demands a reality far stranger than our senses reveal. The mathematics insists on it. Most versions of string theory require 10 dimensions, 9 of space and 1 of time. This isn't just a mathematical curiosity, it's a necessity for the theory to function. These extra dimensions aren't optional, they're essential for the theory to make sense. But if they exist, why don't we see them? Where are they hiding? String theory suggests these hidden dimensions are curled up so tightly on scales far smaller than atoms that they're invisible to us, tucked away in the fabric of reality itself. The precise shape and structure of these hidden dimensions could determine the properties of every particle and force in our universe, influencing everything from gravity to the behavior of light. In this way, the unseen cosmos, the hidden dimensions and vibrating strings, may be quietly shaping reality itself, weaving the very fabric of existence with tiny, harmonious vibrations. 9 spatial dimensions are hard to imagine, but analogies help us bridge the gap between what we know and what lies beyond our senses. Our minds are wired to understand the familiar 3 dimensions: length, width, and height. But string theory asks us to stretch our imagination much further. Picture an ant on a tightrope. From far away, the rope appears as a simple line, just one dimension, easy to grasp. But the ant's world is richer than it seems at first glance. Up close, the ant can walk not only forward and backward, but also around the rope's circumference, a hidden second dimension that's invisible from a distance. This simple analogy hints at the hidden complexity of our own universe. String theory suggests our universe is similar. We experience 3 large, extended dimensions, but at every point in space, 6 more are curled up in a fantastically intricate shape called a Calabi-Yau manifold. These shapes are so tiny and complex, they escape our direct perception. These extra dimensions are unimaginably small, far beyond the reach of even our most powerful microscopes. They exist at a scale billions of times smaller than an atom, woven into the very fabric of reality. We're simply too large to move into them, like enormous ships unable to fit into a microscopic harbor. Our size limits us to the familiar, leaving these hidden dimensions out of reach. But for the fundamental strings that make up everything in the universe, these tiny, curled-up dimensions are home. Strings vibrate and move through all available dimensions, not just the ones we see. The way these extra dimensions are folded and connected isn't random or arbitrary. Their structure is precise, and it shapes the universe in profound ways. The geometry of these hidden spaces determines the properties of the strings, such as their vibration patterns, and in turn, the fundamental laws of physics that govern everything we observe, from the tiniest particles to the largest galaxies. In this way, the hidden shape of the cosmos orchestrates the reality we experience, influencing everything from the behavior of light to the formation of stars and galaxies. Our universe's deepest secrets, its origins, its fate, and its true nature, may be encoded in these invisible dimensions, waiting to be uncovered by future explorers of science. The unseen truly shapes the seen, reminding us that reality is always richer and more mysterious than it first appears. Why should we care about hidden dimensions? Because their discovery would revolutionize our understanding of reality. They could explain dark matter and dark energy, the mysterious substances making up most of the universe. Some physicists think gravity might leak into extra dimensions, making it seem weaker than other forces. This could solve the puzzle of gravity's weakness and unify all the forces of nature. Hidden dimensions might be the key to a true theory of everything. They could reveal why the universe is the way it is, from the tiniest particles to the largest galaxies. Discovering them would be the ultimate breakthrough in physics. The quest for extra dimensions is a quest to unlock the universe's deepest secrets. Theories are exciting, but science demands evidence. We can't see extra dimensions directly, but we might detect their effects, like shadows, at the Large Hadron Collider, LHC, in Switzerland. The LHC smashes protons together at incredible speeds, recreating conditions just after the Big Bang. Physicists look for missing energy in these collisions, energy that seems to vanish, possibly escaping into hidden dimensions. If a particle, like a graviton, slipped into another dimension, our detectors would see less energy than expected. Finding this pattern would be strong evidence for extra dimensions. So far, no definitive signal has appeared, but the search continues. Each collision brings us closer to an answer. The hunt for hidden dimensions is one of the most thrilling frontiers in science. The quest to understand the universe is humanity's oldest adventure. The idea that our reality is just a slice of a larger multidimensional cosmos is mind-expanding. Whether string theory is right or not, the search itself pushes the boundaries of knowledge and technology. We're confined to a tiny planet, but through science we can reason about the very fabric of reality. We build theories and machines to test them, reaching for answers beyond our senses. As we stand on the brink of new discoveries, the coming decades may reveal the true dimensionality of our universe. What we find could confirm our wildest theories, or surprise us with something stranger. One thing is certain, the universe still holds many secrets. The grand cosmic tapestry is far from complete. The adventure of discovery is only just beginning. The unseen cosmos awaits.